Hi everyone, today we're going to go over 5.3, which is the fundamental theorem of calculus. As the name suggests, this is one of the most important sections in calculus. So the message for this section is that integration is the inverse of differentiation. So that's how we are connecting integration to the differentiation that we already know. The fundamental theorem of calculus has two parts. Let me talk about part one. If I have a function going from A to B, along the way, if I have an x, and this area is represented as g of x, and that's my function f of t, part one of this theorem says if g of x is equal to the integral from a to x of f of t dt, then we can conclude that g prime of x, derivative of this function, is equal to f of x. All it's saying is that I need to plug in x for the t for this function. Okay, let me do number 9. For number 9, I have g of x, which is equal to the integral from 0 to x square root of t plus t cubed dt. Okay, let me compare it with what I got. Okay, so that's g of x. Now this function is f of t, so this function is f of t, right? Okay, so it's said g prime of x, so g prime of x, it would be equal to f of x. So I have the function, I just changed the variable to x. So that's the square root of x plus x cubed, right? All right. Let me talk about part 2, which is really important. And that's how we can find the definite integral. So it said if f, lowercase function f, is continuous on the closed interval from a to b, then we can write that the integral from a to b of f of x dx is capital F evaluated at the upper limit minus capital F evaluated at the lower limit, where that capital F is the antiderivative of that lower f, right? Okay, let's see if we can use that formula to evaluate these integrals. Okay, let's start with number 25. The integral going from 1 to 3 of x squared plus 2x minus 4 dx. Okay, now I need to use a formula for that. If I have the integral going from a to b of x to the n power dx, I will put it in the bracket x to the n plus 1 over n plus 1 evaluated from a to b, and make sure that n is not negative 1. Okay, let me follow that formula. So that's going to be equal, put it in the bracket. So put x squared in the numerator with the exponent in the denominator, add 1 to both. Okay, plus If you know that you could write x squared for 2x, that's fine. If not, as you know, you're going to rewrite that constant, put x to the first power in the numerator, the exponent in the denominator, you add 1 to both, right? And if you have a constant, that would be that constant times your variable, which is x, right? Going from 1 to 3. Okay. First of all, let's simplify that. So this is 3, and this is 2, right? So what I have is what? X cubed over 3. Now these 2's cancel out as you expect. So you get x squared minus 4x going from 1 to 3. Now plug in the upper limit minus when you plug in the lower limit. Let me do it here. Plugging in the upper limit gives me 3 cubed over 3 plus 3 squared minus 4 times 3 minus, now I want to plug in the lower limit. So I get 1 cubed over 3 plus 1 squared minus 4 times 1, right? Everybody okay with that? Okay. Let's see. 3 cubed is 27. 27 divided by 3, that's 9, right? So let me write it. 27 over 3 plus 9 minus 12 minus. I have 1/3 plus 1 minus 4. Okay, let's see. So this is actually 9 plus 9 minus 12, right? So this is 1/3 minus 3. Okay, let's see. 9 plus 9, 18, minus 12, that's 6, right? Minus 1/3 plus 3. If I multiply that negative in. 6 plus 3 is 9. 9 over 1 minus 1/3. So that's 3. 27 minus 1. That gives me 26 over 3. Right? Have a great day, everyone.